What lies beyond the edge of space? First, there is no wall, only a limit to what light has had time to reach us. The universe has an age. Light travels finite speeds. Together, they draw our current boundary. Astronomers call it the observable universe, a sphere centered on the observer. Its outer limit today is the particle horizon, the farthest light that could have arrived since the Big Bang. Pictures may suggest an edge, but in space itself, nothing special happens there. Beyond our horizon, the cosmic web likely continues. Filaments, clusters, and wide dark basins. Voids are underdense regions, vast, but not empty, woven into that larger pattern. Filaments bridge these gaps, channels where galaxies and gas flow. Nodes are the traffic circles, clusters and superclusters where flows meet. Closer to home, the local group, Milky Way, Andromeda, and their dwarfs. We drift along a filament's edge inside our own observable sphere, with the local void nearby, a reminder that structure is uneven, yet none of this forms a boundary in space, only in what we can see. Pull back to Laniakea, our greater flow basin, still inside our visible bubble. Gravity sculpts currents, expansion stretches space, carrying distant realms away. Underdense doesn't mean lifeless. Galaxies form and shine throughout the web we can reach, but statistics shift with scale. Fewer neighbors in voids, more in crowded walls. Dark energy accelerates the expansion. Structure carves the rest. No violation of relativity. Map the sky, and the pattern emerges. Our horizon simply marks how far light could travel. Redshift surveys trace filaments and voids. Together, they define our observable cosmos. We live inside that bubble of visibility. Next, horizons. How they work, and what they hide. We start with horizons. What we can see now, and what we can ever see. 3 ideas. Past light cone, particle horizon, event horizon. Your past light cone is all light that has had time to reach us by today. From nearby stars to the ancient afterglow. The particle horizon marks the farthest distance we can see right now, the edge of today's observable universe. The event horizon is different. With dark energy acceleration, it limits which signals can ever reach us in the future. No edge, no wall, just limits set by time and expansion. Horizons mark reachability, not the universe's boundary. Redshift gives distance intuition. As space stretches, wavelengths stretch. More distance. Older light. Some galaxies recede faster than light. That's allowed. Space itself expands. Relativity forbids faster than light motion through space, not of space. Think Hubble flow plus small peculiar motions. Horizons depend on the overall expansion, not on local drift alone. Light emitted today from beyond the event horizon will never arrive. We can see some galaxies now, yet future signals from them won't reach us. Draw the cones. Past light cone shows what arrives today. Future light cone shows where our signals can go. In an accelerating universe, the event horizon is finite in proper distance, a hard limit on future contact. Redshift roughly tracks distance because expansion adds with time. Higher redshift means earlier emission and more stretch. Peculiar velocity adds small scatter, but the horizon story is set by expansion history, the big smooth trend. Combine redshift with models of expansion, and we map the observable sphere, our particle horizon today. Inside that sphere, structure stands out. Voids, filaments, nodes, the cosmic web we actually observe. Denser walls and superclusters glow in surveys. Emptier regions fade. Pattern within our light cone. Laniakea, Virgo, Perseus Pisces. Names for flows and basins we infer within the observable universe. Key idea, no cosmic edge. Horizons are about signals. What light can reach us, and what cannot. Today's map, set by the particle horizon. Tomorrow's contact, limited by the event horizon. Emptier regions don't change the concepts. They sit within our cones, shaping flows but not the horizons themselves. Geometry and statistics agree. With acceleration, an event horizon appears. Observations support that expansion history. Labels help, but they aren't borders. Particle horizon, event horizon, past light cone. Maps of reach, not rims of reality. In short, we see within a growing past light cone. We'll never hear from beyond the event horizon. Next, the thermal rain and what survives. Our horizon is a limit of view, not a wall. Beyond it, the cosmic web likely continues. Same rules, same statistics, so far as evidence suggests. Galaxy surveys fade with distance, but their pattern is stable on large scales. Filaments, nodes, and voids extending past what we can see. The cosmological principle, tested locally, assumes no special place. Extrapolated, it implies more of the same web beyond the light cone edge. Simulations that match nearby maps also predict continuity, structures repeating in kind, not in exact detail, beyond our horizon. Now clearly marked as speculation. Inflation may have seeded regions larger than our observable patch, domains with the same physics. In some models, quantum ripples, stretched by inflation, create slightly different patches, still LCDM-like, but with tiny statistical quirks. Evidence status: unconfirmed. Our data test inflation's broad predictions, not the existence of faraway patches we cannot access. Some versions go further: an inflationary multiverse of many bubble domains. Hypothesis only. Interesting, but not established. Could space be subtly curved beyond our view? Current constraints say near flat. Any curvature must be gentle on scales larger than we see. If curvature exists, it changes global shape, not local physics. Galaxies still form, filaments still thread, voids still widen. Another idea: repeating topology. Space that wraps around. A finite but edgeless cosmos, with echoes across the sky. We searched for circles in the sky, matched patterns from light looping the universe. Result so far: no convincing repeats. Thus, simplest reading stands: near flat, non-repeating, statistically uniform on the largest scales we can test. Beyond the horizon, dark energy still accelerates expansion. The web thins slowly, and islands of light drift apart, much like here. Our instruments infer, models project, but we label the boundary: measured inside, inferred beyond, unknown farther still. What would count as evidence for other domains? Perhaps a collision scar in the CMB or distinct statistical anomalies, none confirmed. What would test topology? Clear repeated sky patterns across wide angles, searched, modeled, and so far absent. What anchors near flatness? CMB peaks, lensing, and galaxy clustering, multiple probes converging on a consistent geometry. So, beyond our sight, the prudent picture is continuity. Same physics, same web, until evidence says otherwise. Hypotheses remain on the table. Curvature, topology, inflationary domains, kept, but clearly marked as conjecture. We separate map from margin. Observe structure here. Plausible extensions just beyond. Bold ideas far beyond that. As distances grow, certainty fades. Still, the pattern's logic, gravity, expansion, initial ripples, travels with us. Tomorrow's surveys widen the test, deeper redshifts, finer lensing, sharper statistics, to push that frontier out. For now, we say, beyond our horizon lies more universe, likely familiar, possibly surprising, awaiting evidence. Hold the distinction: evidence versus conjecture. Next, we return from the edge to consequences closer to home. After the Big Bang, the young universe was almost smooth. Tiny ripples in a glowing fog. That snapshot is the cosmic microwave background, our baby picture of the cosmos, not a hard shell around us. We see it in every direction because we're looking back to the surface of last scattering, when the plasma turned transparent and light streamed free. We sit at the center of our light cone, not the universe. Those faint hot and cold patches trace ancient sound waves, acoustic ripples in the primordial plasma that later guided where matter gathered. Plot their sizes and strengths, the CMB power spectrum, and peaks emerge. They encode the sound horizon, the mix of matter and light, and how fast space was growing. The first peak's angular scale points to near-flat geometry, space that, on large scales, isn't curved much at all. Even topology leaves clues at the largest angles. Searches for matched circles, rings in the sky, test whether space might wrap around in subtle ways. Polarization and weak lensing add depth, refining the map and tying early ripples to later structure. From those initial ripples, gravity amplified contrasts. Filaments bridged nodes, walls stretched, and surrounding voids kept expanding. Most of space is empty. Matter sketches a thin, luminous skeleton through the dark. Where threads cross, clusters grow, gravity stacking halos into cities of galaxies. Billions of years pass, expansion continues, gravity builds structure, dark energy later slows new growth on the largest scales. Mergers sculpt halos, feedback stirs the gas, the web sharpens its lines. Inside halos, disks and spheroids assemble. Stars forge elements, explode, and recycle matter. Zoom out. The universal pattern. Voids, walls, filaments, and nodes woven across the sky. Our local group sits in a modest filament near a broad void, typical, unremarkable, and real. We orbit an ordinary star in a common spiral galaxy, one node among many on the map. From CMB ripples to a lattice of galaxies, statistics and simulations agree. The pattern holds. No single step, rather a chain. Tiny density ripples, gravity and dark matter, cooling and feedback, web from simplicity. We map it with galaxy surveys and weak lensing, light bent by mass revealing hidden structure. Simulations and data align on large scales. Details sharpen as instruments and models improve. The lesson is grand and simple. Small differences, long times, and gravity. Structure emerges. We are ordinary inhabitants of a sparse patch in a vast web, reading yesterday's light to know what lies beyond. Fact 2. Surveys reach beyond sight, reading patterns in light to hint at the size and shape past our horizon. Standard candles, type Ia supernovae, act like calibrated bulbs. Their brightness sketches a map of distance versus redshift. Anchored nearby by Cepheids and TRGB, these lights trace expansion cleanly. Our local yardsticks scaling to cosmic spans. Plot them and you see Hubble's trend. On average, farther means faster, as space itself stretches between galaxies. Baryon acoustic oscillations add a standard ruler. Ancient sound ripples frozen into galaxy spacing, letting us check scale and curve. Weak lensing reads the sky's faint shear. Tiny shape stretches that reveal where mass hides, independent of starlight. Together, candles, BAO, and lensing triangulate geometry, finding near flat curvature and tightening how big space must be. Standard sirens, gravitational waves, carry distances in their waveforms, a ruler that needs no light at all. And 21-centimeter cosmology listens for neutral hydrogen's whisper, radio maps that chart structure across deep time. Topology tests hunt repeating patterns, match circles and echoes that would betray a small, wrapped universe. None so far. Local structure nudges measurements, but wide field maps average over it. Clarity grows with area, depth, and numbers. Redshift surveys like DESI draw the web in millions of points. Filaments, basins, and the BAO ripple stamped through it. Cross-checks matter, candles with sirens, BAO with lensing, independent paths that break biases and tighten the map. Craft makes precision. Stable instruments, careful zero points, uniform pipelines. Quiet work that earns trust. The CMB anchors the early script. Late-time tracers write the sequel, together constraining curvature and growth. Peculiar velocity maps and flow tracers add motion clues, another lens on gravity's tides across the web. Radio arrays and KSZ surveys weigh cluster winds, signals of large-scale flows that test our cosmic model. Time delay lenses clock light's detours, turning gravity's geometry into distances and cross-checks on H0. Each method sees differently. Agreement is the point. Overlap that shrinks uncertainty and corners the truth. Wide, weak lensing maps weigh the line of sight, calibrating magnification so candles and sirens read cleanly. Results so far. Space looks vast and nearly flat. Exotic wraparound shapes must be larger than our visible patch. Precision is earned. Cross-calibrated bands, repeatable reductions, open tests, evidence first, story second. Structure nudges light and motion. Gently, not headlines but bookkeeping that makes tomorrow's map tighter. We cannot see beyond the horizon, but patterns let us infer. Curvature, scale, and how far the web likely runs. Next-gen maps, Roman, Rubin, and the SKA, will widen the sky, deepen time, and sharpen every cross-check. That is why surveys matter. Many eyes, many methods, converging on a universe larger than we can directly see. Cosmic expansion accelerates. Dark energy stretching space faster with time. That acceleration creates an event horizon, a far receding limit to two-way contact. Our observable radius grows with age, yet the communication horizon stays finite. Picture a light cone. Past light comes to us. Future light from us can reach only what lies inside that horizon. The edge is time-dependent. Some galaxies we see today will slip beyond all future messages. Their light redshifts and fades toward whispers, then silence. Gravity keeps the local group bound. Beyond it, groups drift apart as space grows between them. The horizon recedes slowly in proper distance, while more structures cross it in comoving terms. We may still see their ancient light, but no future signal can bridge the growing gap. On long timelines, billions, then trillions of years, the distant web freezes from view. We measure this now with supernova clocks and baryon ripples, evidence that expansion accelerates. The CMB and cosmic geometry point to a dark energy-dominated future. Consequence: fewer new galaxies to study, local archives and records grow vital. Star formation wanes, fuel thins, the universe dims between islands of gravity, communication becomes parochial, messages confined to our bound neighborhood. Yet the observable sphere still grows. New ancient light arrives from just within the edge. The boundary isn't a wall, but a moving line in time, set by what can ever exchange signals. Timeline: acceleration today, isolation later. Islands endure while horizons widen, then empty. Meaning now: measure well while the sky is rich. Calibrate, compare, preserve. Our place is a small island with long memory, connected for a while, then mostly to itself. The edge recedes as the night deepens. Keep the lights, keep the maps, keep watching. After the fires, the sky cleared, and so did our view of where we live. Light returned, and with it, a question. What is our place in all this? We are not at the center. We orbit a star in a modest arm of a common galaxy. Our neighborhood is thin and dimmer than most, quiet lanes between brighter crowds. Astronomers call it a cosmic hole, a local underdensity where galaxies are sparse. Living in a low-traffic lane teaches humility and sharpens curiosity. We map from here outward, measuring, comparing, testing. Telescopes under dark skies trace stars, gas, and dust, our quiet corner to the rim. Distance is our compass, motion, our clock. We read redshifts and standard candles, small lights that fix great spans. We chart flows, how galaxies drift along the web's filaments. Filaments gather, voids relax. Our path is one current in a larger sea. The more we measure distances, the more tomorrow's sky becomes predictable. Motions reveal tides of gravity, subtle pulls that steer our long future. Clarity grows step by step, map by map. We find that quiet regions like ours are part of the pattern, not an exception. From local stars to the deep survey lines, the picture resolves. We are a small light between larger lights. That is enough to begin. Awe invites care. Perspective invites patience. We live inside structure, woven, not central. Predictability grows with every measured distance, every careful flow. And still, there is work. Steady, quiet, cumulative. Observatories keep watch. The data keeps coming. Each survey knits another thread in the map. Evidence first, then story. That is how we find our place. From parallax to standard candles to deep time baselines. The map expands, our assumptions shrink. Edges become questions, not walls. Galaxies drift on gentle arcs, crossing epochs we only sample. Patience is coded into the sky itself. Variety blooms where structure allows, on land, in sea, and between stars. In this thin, dimmer neighborhood, life learned to look up. Time is the medium. Attention is our tool. Causes and consequences, traced by light, written in motion. We keep warmth by understanding where we are. The chapter begins with humility and continues with measurement. We read the past to forecast the path ahead. That we can do this at all is both astonishing and grounding. We are witnesses and stewards of a small light in a vast weave. Curiosity builds instruments. Care guides what we do with them. We read tomorrow in today's light. Models meet rock, spectra, and time. Evidence decides. Birth and death of stars, shifting continents, climates and shields. Context for home, detectives of the cosmos, caretakers of a habitat still healing. This isn't only observed, it's lived. Wisdom is choosing to measure well and to act with what we learn. Each discovery deepens awe and responsibility. Our task is grand and patient. Timescales dwarf us. Attention still matters. Feeling small can sharpen purpose. Beauty and truth travel with duty. Tonight, Earth's blue glow rests in a wider dark. Far beyond, stars forge and fade. Quiet engines of change. Endings and beginnings frame our place and our task. Keep a light in the dark. Keep a record in the noise. Give meaning to our brief, habitable instant. For now, the stars still shine. Galaxies still drift on graceful arcs. And here, we keep watch. Learning, measuring, preparing. New missions will sharpen our limits. Tonight's light carries memory and direction. Each dataset widens the view. Our location, a faint lane between brighter filaments, an edge that invites questions. Pull back. From our dot to the cluster to the web, an edge becoming a horizon of knowledge. What future moves you to act, so clarity guides our hardest days? Hold this warm, sunlit instant. Measure it well. Each reading pushes the horizon. We live in a cosmic whole, on a small light. Stay curious. Care for home. Beyond the edge lies tomorrow's data.